Hi students, welcome to my channel. I am Engineer UD. Today on the physics channel we are looking into a request video which was sent to my mail as usual. So if you are a first timer or you are new to this channel, you can subscribe to our channel, Mosdeeacademy physics channel, and as well as the modified channel to have a maximum knowledge on science subject and mathematics. Now about the question we have before us, I hope this is clear. We have a 6.5 kilogram, 11.0 centimeter bowling ball rolls down the valley without slipping. Its center of gravity moves with a constant velocity alpha of 15 meters per second. So we have a couple of questions. The first one, we have to find the ball's angular velocity. For maximum knowledge of this particular topic, you can consider watching the full concept video of rotational motion or rotational dynamics on this channel or under the topic of circular motion. You can check it out. You are going to see more and more of what you need about derivation and about applications. So this is some of the application of what we have studied before. Let us start by the use of the formula. So I'm not going to draw because it's going to be a short video. This is not a full concept video. I'm just going to go through the formula and make sure you understand how to use the formula appropriately. The first thing about physics is to check the SI unit. If you watch very well, 11 centimeter bowling ball rolls down, you can see that means something needs to be done. So we have to be careful about that. So centimeter is not the standard unit of what? Of measurement of length or radius or diameter, as the case may be. So 11 centimeter bowling ball means the diameter of the ball is 11 centimeter. So I will need to convert that to radius unit. So let's start with the first. Ball angular velocity. To calculate the angular velocity, we should have learned from our circular motion and rotational dynamics that linear speed is equals to radius multiplied by what? Angular speed. I think that is a direct formula which I believe is popular. So let's start with the solution. So the solution now, we have a solution to that first will be, I'm managing this side to provide the solution. So I'm doing the A part. And for the A part, I have the ball's angular velocity. We know that V equals to R omega. But we are told to call it alpha here. It doesn't mean anything. From the question, we know the V. The V was given, the constant velocity was given to be 15 is equals to the radius. This is where I'm actually trying to explain. Under the radius aspect, now you have to keep something in mind. But before that, you can consider going by this. This is the diameter of the ball. Diameter is equals to 2 times radius. Mathematics. So radius is basically half of diameter. So I'm saying 11 by 2. That will be about 5.5 centimeters. So I have to convert that to meter. I just have to divide 5.5. So the radius is the same thing as saying 5.5 divided by 100 is 0.55. And again, I have calculator for you guys so that you can see. You can see 5.5 divided by 100. I don't want any issue. That's why I'm doing this. Wow, that should be 100. Then we have 0.055. So 0.055 meter will be the value of the radius I am going to use all through the solution of this video. So keep that in mind. So directly we can just solve 15 equals to 0.055 times what you are looking for, which is the angular velocity according to the question. So on simplification, we can say this will give us nothing but angular velocity is equals to 15 divided by 0.055. So omega, which is angular velocity, will just be, you are saying 15 divided by 0.055. Remember, that is 272.72, or I say 272.73. I'm approximately there, radians per second. So I hope you've done that in your junior classes. And that will be the right answer to the first question. So that is the correct answer for this. So please keep it in mind. I think it's simple. So just be careful that you need to convert. If you've done conversion, I don't think there is another problem that is difficult to do. Now, the second question, about the second question we have is we have to calculate its kinetic, translational kinetic energy. That is a linear kinetic energy, not the rotate. You know, the ball will rotate and it's going to have rotational energy. That's what we call the moment of inertia. All those things are available on this channel. You can check. Now, kinetic energy from junior class is half mv squared, linear velocity, not angular, linear speed or linear velocity. So that's just direct. So let's do that directly. I think this is also very simple. So we can just come here and say the B part. The B part is asking for linear translational kinetic energy. We just talked about that is half mv squared. So if it is half mv squared, just distribute the formula. That's half times the mass was given in the question to be 6.5 multiplied by the square of the velocity. 15 times 15 is 225. So 225 times 6.5 divided by 2. I'll also do that here for everybody to see. 225 multiplied by 6.5. We are dividing the answer by 2. So I think that should be 731.25. Energy is measured in joules. That is absolutely correct. So I think all these are basic questions. That's only testing you on your knowledge of understanding of basic formula. So that is the second answer. So we look into the third one. I hope you are getting this. The third one will be what we're going to do now. The third one should be, let me see. Yeah, if I can see a space to manage. The third one says the moment of inertia. So that is what we're talking about, because that will be what? Because it is rotating, definitely you expect what? The moment of inertia I to come in. Now, the moment of inertia of a ball is given by 2/5. Please note that nr squared. The moment of inertia, a ball is classified to be a sphere. Please note that. So moment of inertia of a sphere is given as 2/5 mr squared. So let's do that together. C part, I'm going to manage one part of this side so that we can actually have it done correctly. So let's take this black. So the C part, let me manage this to do the C part. And about the C part, we have the moment of inertia. Its moment is m, capital M equals to 2/5. And see, we have m, small letter m, r squared. Now, substituting the moment of inertia is now equals to, you can call moment of inertia I in some cases, so that I won't have, let me call it the normal symbol for you guys. And when we are doing other questions, you won't have use. It's just representation. So the moment of inertia is also I. Inertia. Second law of motion. Now you have I. Wow. So that is I is equals to, so now we have 2/5. The mass was given to be 6.5 multiplied by the radius square. The radius I'm using is 0.05055 all square. So I'm going to punch that also on calculator, and if I punch that on calculator, let's see what I'm going to have. 0.055 squared first. So we can see this is 0.0. This is not a scientific calculator, so I just have to manage that. Multiply by 6.5. 0.5. Then multiply by 2. That is 2. Then we are dividing the answer by 5. Divided by, I cannot even see division. So this is division. Hopefully it will be divided by 5. So that is 0.007865. I'll write everything. So 0.07865. Now you can convert if you want to convert, because it's important sometimes. You can just leave it in maybe 4 significant figure, 3 significant figure, 3 decimal place, you follow it. Then about the mass is measured in kilogram, radius is measured in meter. So meter square multiplied by kilogram. So just note that. So you can write kilogram meter square. So as the SI unit, it's acceptable. So that's that. The next one, which I'm going to quickly do because of time. We don't have the time. This is the answer to the first one. So maybe I'll leave the last one for you guys to attempt, at least for the sake of knowing that you're actually flowing with me. At least let me know you are flowing with me. The fourth one, I may manage that side. Let me say the first one says, the fourth question says the rotational kinetic energy. So I told you it is actually rotating. So kinetic energy linear is half mv squared. Rotational kinetic energy is half times the moment of inertia multiplied by the what? Angular velocity squared. You can see here, is it? Kinetic energy is half mv squared. Rotational kinetic energy is half moment of inertia multiplied by the angular velocity. It will not be linear again because it's now rotating. So just keep that in mind. So we can just also manage that at this side of the board. So we have rotational kinetic energy. Rotational energy is just half moment of inertia times angular velocity all squared. So distribute the formula, you can finish this. So it will be half multiplied by moment of inertia answer is 0. I won't use everything. 0.07865 multiplied by, I'm using that's omega square. Where's my omega? 272.73 square. Don't forget you have to do this and divide by 2. So that is that. So energy is always in joule, no matter how it is. So we can do it together. So this guy square, okay, it's not square, 0.0785 times. And I'm not sure this guy can multiply something in square. 272.73 square. 272.73 square. So that's the issue. Okay. Hopefully it will be correct. 585.0. So I can just say 585 joules. I will just write that. So 585. So as a rotational kinetic. So that is that. Then the last question, like I said, the last question is, look at that. I will leave that for you to solve. It's kind of simple. The fraction of the total kinetic energy that is, this is the total kinetic energy. The fraction of the total kinetic energy that is rotated. What fraction? This is the linear kinetic energy. It is the what? Total energy, rotational kinetic energy. Going by the fraction, I think I have to divide this guy by 2. I don't know, maybe I have to divide it. You can check this because it's important for us to get all answer. Let's do it another to check the answer here. 272.73 square. I want to confirm that. 272.73 square multiplied by 0.007865. Wow, multiplied by 0.00785. I should divide the answer by 2, I know. Divided by 2. Because I know it's half. So the answer should be, apologies guys, should be half of this. So I'm going to clean that. So that's, I didn't divide by 2 because it's half of this answer. So the answer here should be, because I know something is wrong. Now, 292.5. 292.5. So let's take that as the answer to that. So now, look at the question. I love this question. Now, the question now says the fraction of the total kinetic energy. Where is total kinetic energy? 731.25. The fraction of total kinetic energy that is rotated. What fraction of this is rotated? So compare this guy and this guy in terms of what? In terms of fraction. So what fraction of this? Only 292.5 is rotated out of 731.25. Just put them in fraction and you are going to get your answer. So guys, I'm going to be stopping here. If you are new to this channel, you can, if you enjoy what you are seeing or what you've seen so far, you can consider subscribing to the channel See you guys in the next class. If you have a request video, do send it to Mosdeeacademy@gmail.com. I'm going to attend to all your questions, and some of them are always brought here as a video for everybody to see. So I will see you hopefully next time by the grace of God. Very soon I'll be back. Bye for now. Thank you.